Right, lesson 2 in unit 3, we're looking at finding missing measures. So if you have a side length that you want to find, or if you have an angle measure that you want to find, this is what this video is about. So if we look at this one here, if it tells us we have a right triangle, it has a 20-degree angle in it, and the hypotenuse is 5. Alright, so I'm just going to note our little Sokotoa thing up here. And we're going to refer to this all the time. So it says find the length of AB first. So it's this side down here, which I'm going to call X. And we're going to find the length X. So what we're going to look at, with the 20-degree angle, we know the hypotenuse and we want to find the adjacent. So that means we use the cosine ratio, because cosine is adjacent over hypotenuse, right? So if we set that up, we know that the cosine of 20 is equal to x over 5. And what the cosine of 20 tells you, right, when you plug that into your calculator, it tells you that when you compare the adjacent to a hypotenuse in a right triangle, which is a 20-degree angle in it, you're always going to get the same value, which in this case is, type cos 20 in your calculator, it's 0.94, okay, if I round it to 2 places. So 0.94 is what cosine of 20 is, and that's x over 5. Right? And now you solve it from there. What's x? Well, you do 5 times 0.94, and it gives you 4.7. Okay, please ignore the screaming kids outside. So that's what we got. 4.7 is x. Now, it asks us then to find the side BC. We can do the same type of thing. BC, we can call that y. And because BC is opposite to 20, we could use opposite, we could do y over 5 equals sine 20. Or we can also use Pythagoras' theorem. Pythagoras' theorem will tell us that 4.7 squared plus BC, we're going to call y, plus y squared is equal to 5 squared. Okay, and we can work from there, and that will give us, being able to use Pythagoras' theorem, which we should know, will be able to give us the measure of the side y. Okay? Right, let's look at the next question on it. So, similar, just something different comes up. So we're going to find the length of AC first, and AC in this case is the hypotenuse, so we're going to mark that as x. And something a little bit different comes up here, so we're just going to be careful with that. So, in this case, the 45-degree angle, again we have the adjacent, but this time we want to know the hypotenuse. So it's adjacent and hypotenuse that are connected in this question. So again, it's cosine. So we're going to say that cosine of 45 is equal to 3 over x. Now, let's type into our calculator, what's cosine of 45? Cosine of 45 is 0.71. So 0.71 equals 3 over x. Now, be careful, because the x is on the bottom here, it presents us with a different problem, right? So what I'm going to do to help us to solve this, I'm going to make the 0.71 over 1 to make it like a fraction, and then we can just cross multiply. So 0.71 x equals 3. So x equals 3 divided by 0.71, which works out to be a little bit over 4, I suppose. Let me check with that. And it gives us 4.2. Alright? So x works out to be 4.2, and again, to find the other missing side length, we can just use Pythagoras' theorem. Okay? And also, look, if we were asked to find the measure of the angle at C, well, it's going to be 45 degrees, right? So now, let's go on to the next page to see. So in the next one, here, see if I make it a little bit bigger. We're going to have to find angle measures, right? So here we know all the sides and we're trying to find angles. So look at the angle alpha. Now I can use any ratio I want, because if you look at the angle alpha, I have the opposite, I have the adjacent, I have the hypotenuse, so I can make sine, cosine, or tan if I want to. Okay? So here's how this works. This is a little bit different. So I'm going to decide in this case that I want to use the sine ratio. So sine of alpha is going to be opposite, which is 8, over hypotenuse, which is 17. All right? Now, because of the way that these ratios work, what I have to do now, I have to ask my calculator what angle gives me 8 over 17 when I divide the opposite by the hypotenuse. Okay, so this is where you use the inverse function. So what I'm going to type into my calculator is sine inverse of 8 over 17. And that's going to tell me what the angle is. So I'm basically asking my calculator, what angle has 8 over 17 as its sine ratio? So you press shift sine, and you can put in parentheses 8 divided by 17, and it gives you 28 degrees. Yeah, about 28 degrees, if I round it to the nearest degree. And if alpha is 28, well then, it means that the other one must be 62, because they have to add up to 90, right? Let's go down a little bit further. So again, we're trying to find, in this one here, we're just going to find the two angles in B, right? We're not even going to try to find the measure of the side A. We don't want to know that necessarily. It's the two angles. So let's say I'm going to start with this angle here, and I'm going to call it alpha. Now, I know two side measures here. One of them is A. I don't know what it is, so I have to use the two that I know. So because I know the hypotenuse and I know the adjacent, it's the cosine ratio that I'm going to use. So I know that cosine of alpha is equal to 9 over 12. All right, so now, because I know the cosine of the angle, I have to ask the calculator what's the actual angle. So I do cosine inverse of 9 over 12, which is 3 over 4. Put that in. Shift cosine 9 divided by 12, and it tells me that it's 41.4 degrees. All right? And if that's 41.4, well, the other one is going to be supplementary or complementary to it, so it's going to be about 48.6 degrees is the other angle, okay? Because we know they have to add up to 90. And then we're going to move on to the last slide now to have a up. And this one here, it's asking us, we're solving the triangles, right? So basically what that means is find out all missing side lengths and angle measures. So let's start. Let's look for the easiest thing to work out. So here, because we have two angles, this angle at A, angle A is going to be easy to work out, isn't it? Yeah? Excuse me. Oh, sneezed. The angle at A has to be 28 degrees. We should know why. Because 62 and 28 is 90. Those two have to add up to 90. Right. So that's the angle A found. Now, let's look at the side BC, and we're going to call that X. So I'm just going to box off A to show that that's the first thing that we needed to find is done. Okay. So if I want to find BC, I know the opposite, and I want to find the adjacent. So that's the tan ratio. Okay, I don't know the hypotenuse, so I can't use the hypotenuse in my ratio. So I'm going to say that tan of 62 is equal to 25, which is the opposite, over the adjacent, which is x. Okay, now plug it into my calculator. Tan of 62 is what? It's 1.88. So, okay, we'll just put it as 1.88, 2 decimals. 1.88 is equal to 25 over x. Now you put that down, you cross multiply it, you're going to get 1.88 x is equal to 25, so x is equal to 25 divided by 1.88. So it's 13.3. Okay? So x is 13.3. Now, That's one of the sides found. So now the only thing you need to do is find this last side, y, which is the hypotenuse, and you can do that by Pythagoras' theorem. Because you know this, x, you know 25, 25 squared plus 13.3 squared will give you the final remaining side. And lastly, let's look here. Okay, so because I know two sides of this right triangle, I can find the side AB, which I'm going to call x, by using Pythagoras' theorem. 30 squared is equal to 24 squared plus x squared. Okay? So you work that out, and that's going to help you to find what x is. So now we need to find the two angles. So I'm going to call this angle in here theta. Now, how am I going to go about finding that angle measure? Well, if you look at it, the angle theta, I know the hypotenuse here, I know the adjacent, so I'm going to say cosine, because it's adjacent hypotenuse. Cosine of theta equals 24 over 30. So that means that theta is equal to cosine inverse of 24 over 30. So I'm just going to put that in my calculator, shift cos 24 divided by 30 equals 36.9 degrees. Okay, and because we know that's 36.9 or 37 degrees, we know that this angle here must be about 53 degrees because it has to add up to 90. Okay, so that's pretty much it. That's how you solve right triangles. And there's our first two lessons complete in trigonometry, okay?